Good morning, this is Mrs. Webb, and we are going to do a video on solving by substitution. Okay, I'm going to go a little bit fast because I know that you can stop this at any time and take notes. However, I'm not going to go too fast because this is like my 6th time to try it and I keep making mistakes. So let's see if we can get through this one. The last lesson you did was graphing by, was solving by graphing. And it's slow, it's not always very precise. The second method that we usually like to use is by substitution, and you're going to use all your algebra skills, but you'll get a precise answer. So let's get started. I'm going to walk through some examples for you. Okay, if I had this system of equations right here, there's 2 of them, and I wanted to solve by substitution, I want to get one of my variables all by itself. And we're fortunate on this one. Both of them, I have y by itself on the first one and y by itself on the second one. I'm going to pick this one here and I'm going to box this right there. Now I know y is equal to whatever is in that box. And what I'm going to do is I'm going to substitute that box in to the other equation right there, because I know y is equal to whatever's in that box. So I write the first equation down, and when I put y, I'm going to go take what's in that box and I'm going to put it right there. Now I'm going to use all my skills of algebra to solve for this. When I have variables on both sides, I want to get them all to one side. So I'm going to subtract 3x from both sides, and I end up with x, that would be 1x, plus 2 is equal to, those are 0, they cancel, 1. Now I still need to get x by itself. I'm going to subtract 2 from both sides, and I get x is equal to -1. Okay, but I haven't solved the system yet because I have 2 variables. I need to know what y is equal to. So I know x is equal to -1. I can plug x equals to -1 into either of the equations up above. I'm just going to do it with the first one. Y equals 3, and what's x? -1 plus 1. Y equals -3 plus 1. Y equals -2. So if you graph these 2 lines up here, they would intersect at -1, -2. Let's try another one. So for this one, I only have one equation where the variable is all by itself. And you know, Miss Webb's always about doing it the fastest way and the most efficient way. And x is already by itself, and I don't want to do any more work. So I know that x is equal to 2y. So I'm going to take that box and I'm going to substitute it into the equation below. So if I came down here, I'd do 2 times x, but I know x is equal to 2y minus 2y equals 14. Now I have to distribute, I have to multiply here. 4y minus 2y equals 14. 2y equals 14. I divide both sides by 2 and I get y is equal to 7. But I'm not done yet. I need to know what x is. I'm going to go plug this y equals 7 into one of these equations up here. I'm going to pick the first one because I want to do it the easiest way possible. And I know y is 7. And when y is 7, x must be equal to 14. If you graph those 2 lines, you would get them to cross at 14, 7, that point. You can always double check your answers. This one we've pretty much already done. I have 14 is equal to 2 times 7. 14 equals 14. That works. This one, 2 times, now what's x? 14. Minus 2 times, what's y? 7 is equal to 14. Well, I have 28 minus 14 is equal to 14. That is true. That gives me 14 is equal to 14. I'm going to do another example. Now in this one, I'm going to kind of cry a little bit first because I don't have any variables that are all by themselves. But I want to do this in the most efficient way possible. I'm going to pick this one down here because this one, there's no coefficient on my x here. So I think it would be fast if I just subtracted 4y from both sides. And I get x and 4y minus 4y 0. And I get negative 4 minus 4y. That's a mistake a lot of people make. It's negative 4 minus 4y. Now that's not very pretty, but I can leave it just like that. X is equal to negative 4 minus 4y. And now I'm going to box this right here. And I'm going to substitute this in for x right up there. So I'm going to do 3, and I know x is equal to negative 4 minus 4y plus 5y is equal to 2. So I have to distribute first. 3 times negative 4 gives me a negative 12. 3 times negative 4y gives me a negative 12y. Plus, I bring everything else down. Okay, now I can combine like terms here. I have a negative 12 minus 7y equals 2. Okay, I need to get y by itself. So I'm going to add 12 to both sides. I get negative 7y equals 14. Now I need to divide both sides by negative 7, and I get a negative 2. So if y is equal to negative 2, how do you know what x is? You have to plug it in. And does it matter which one you plug it into? No. I think I'll do it to the first one. 3, and I don't know what x is. That's what I'm solving for. I do know what y is, though. It's negative 2. I'm going to put it in parentheses so I don't get my signs messed up. Okay, I now have 3x plus negative 10 is equal to 2. I need to get x by itself. I'm going to add 10 to both sides. I have 3x equals 12 because negative 10 plus positive 10 is 0. They cancel. Now I'm going to divide both sides by 3, and I get x is equal to 4. So if I graph those two lines, they would cross at 4, negative 2. Let's try another one. Okay, in this one, it doesn't matter whether you substitute x or you substitute y. I'm just going to go for whichever one is easiest and most efficient. And this one, y is already all by itself. So I'm going to box that. And I'm going to substitute that value in for y on the second equation. Okay, I'm going to distribute first. I have that they're equal to each other. In fact, if I tried to get them all on both sides, I'd have to subtract 6x from both sides, and I'd get negative 8 is equal to negative 8. Is that true on planet Earth? Always? Yes. That means there is an indefinite number of solutions that would be true for both lines. Do you know why? Because they're basically the same exact line. Notice this is y equals 3x minus 4. I just multiplied that line times 2, that equation by 2. This is the exact same line. If you went to graph these, you would end up graphing the exact same line. They'd be right on top of each other. And that means anything you picked for x and y would be true. Let's try last example here. Okay, again, y is already by itself, so I'm going to use that one right there. And I'm going to go substitute it in right there. So I'm going to write 3x, but instead of writing y, I'm going to go put what's in my box. Okay, now there's a plus sign here. So I have 3x plus negative 3x is 0, minus 4 is equal to 4. And now I have negative 4 is equal to 4. Is that true? Never. No solution. If I graph these two lines, you would find that they were parallel and they never cross. There's no intersection. That's why there's no solution. And it also makes sense because what is the slope? Well, this is in slope-intercept form, and I know my slope is the coefficient in front of x, which is negative 3. Let's put this one in y-intercept form. If I wanted to put 3x plus y equals 4 in slope-intercept form, y has to be by itself. I subtract 3x from both sides. Look what happens. I have negative 3x plus 4. What's the slope of that line? Negative 3. They have the exact same slope. Okay, good luck with your lesson.